A very good morning to all of you. Myself, Dr. Varun Mishra. Today, I am going to discuss about the architecture and design of distributed database management system. In the previous classes, we have discussed about the types of distributed database management system, different functions of distributed database management system. Today, we will see how we can design the distributed database management system and what should be the architecture of such kind of database. So before starting, first, these are some. This is the important characteristics of distributed database management system. Means transparency is one of the important feature of a distributed database management system. And as we have already discussed in the last class, that transparency may be of different types. It may be based on language. It may be fragmentation transparency. It may be replication transparency, network transparency, data independence, or data. So out of all the transparency, these are the properties of distributed database management system. We will see fragmentation, replication, and network. These three are very important type of transparency feature that are provided by distributed database management system. So now moving to the next slide. Okay, so first we should know what is transparency. So basically, the transparency means how your data is transparent to the user, or how a user can use your database for their specific purpose. Okay, it is based on the network. It is based on the network that is used to protect the user from the operational details of the network, and users do not have to specify where the data is located. Okay, this is the kind of transparency. User should know what kind of data they are using and what kind of data they are dealing with, but they are not allowed to see, or they are not allowed to let the details about the specifications of the data sets. And also the transparency protects the user from the operational details of the network. Whatever the network we are using, or at what network our database is shared, okay, it protects the user from the operational details of the network. Okay, and the user do not have to specify where the data is located. Second important property under transparency is replication. Replicas means copies. Okay, we may have multiple copies of the same database. That is known as replication or duplication. So replicas or copies are created for the performance and reliability reasons, and the replication causes difficult update problems, and users should be made unaware of the existence of these copies. Fragmentation is important under transparency. Basic fragments are part of a relational vertical subset of the column and horizontal subset of the row. Whatever the data you are having, as all we know that the database is stored in the form of table, or stored in the form of in any format. It may be stored in any form, but fragmentation is the process of the division of your database into vertical and horizontal components. Okay, so the basic fragmentation are of two types, that is vertical, that is a subset of the column, and horizontal, that is subset of the row. When we subset the data stored in the column, it is known as vertical fragmentation, and when we subset the data which is stored in the rows, which is known as horizontal fragmentation. So fragments are also created for the performance and reliability reasons, and the user should be made aware of the existence of the fragments. So when we perform fragmentation, so the details of the fragmentation will be available for the users. User will be able to know what kind of fragmentation is there, whether it is vertical fragmentation or horizontal fragmentation. Okay, so distributed database management system, the architecture of such kind of database management system having autonomy, distribution, and heterogeneity. Autonomy means the degree to which each database management system can operate independently. That is distribution of the control or not data. Okay, the entire database, or you can say the database stored in any form of database management system is the autonomy, means all the data sets are independent from each other. No data in one table can affect the data in another table. All the data sets are independent from each other, and all the databases can be operated independently, can be operated separately. So it means that if you are using sub data set, and other person is using another data set of the same type of data, So they are independently operated, they can be independently operated from each other. Okay, so it tells us the distribution of control, whatever the data you are using and how much you are having the control over that data, that is autonomy. And distribution describes where the data is located physically. Okay, the physical location or the directory of the database where it is stored will be described by the distribution. And heterogeneity means it indicates the uniformity of the database. Okay, whether your data is having uniform type of data structure or ununiform type of data structure, that is heterogeneity. And homogeneity, there are two terms. If you are dealing with the same kind of database, then it is known as homogeneous database or homogeneity. If you are dealing with different kinds of database, then it is known as heterogeneity or heterogeneous database. So the heterogeneity indicates how much your database is uniform and what kind of data you are dealing with, whether you are using uniform database or ununiform database with respect to the entire database. Okay, so the architecture of distributed database management system having three components: distribution, heterogeneity, and autonomy. Okay, when we talk about distributed database management system, it should be work together like the distribution, heterogeneity, and autonomy. These three components should work together for very effective architecture, for making good architecture of distributed database management system. If any one of three will not work, then you cannot architect, you cannot design a proper database management system. So all these three components should be there when we are going to design, or when distributed database management system will have some kind of architecture. It is having in distribution, heterogeneity, and autonomy. Okay, so now we will see what is autonomy, what is distribution, and what is heterogeneity. So autonomy will be indicated by the capital letter A, distribution will be indicated by capital letter D, and heterogeneity will be indicated by capital letter H. Okay, so when we talk about autonomy and the having three types, that is tight integration, semi autonomous, or total isolation. If the data is having tight integration, all the data sets are integrated with each other, then we will represent it by A0. If it is semi autonomous, means some part is autonomous, some part is not autonomous, there is a 50-50 of the database which is autonomous and non autonomous, then we will define it by A1. And if data is completely autonomous, if data is completely independent, then we will define it, or we will indicate it by A2. Okay, so depending on the data, or you can say that depending on its autonomy, we may define it by three different signs. These are some symbols: A0, A1, and A2. Now in the same way, distribution is having three types, that is D0, D1, and D2. D0 is non-distributed. If your data is not distributed, then you can indicate it by D0. Okay, and if your database is distributed over a server, then it will be defined by D1. And if it is distributed only one person to another person, that is peer to peer. Peer to peer matlab a person will have the distribution to another person, there is a connection between one to one person, that is known as distribution between one to one person, that is known as peer to peer, and it will be indicated by D2. Okay, and heterogeneity is having different types, like when we talk about same kind of database, then it is known as homogeneous. It will be defined, it will be indicated by H0. And if it is having different types of data sets, your database is of different types, then these kind of data sets are known as heterogeneous data sets, and it will be indicated by H1. Okay, so homogeneous means same kind of database, heterogeneous means different kinds of database. Okay, so under autonomy there are three possibilities, under distribution there are three types, and under heterogeneity there are two types. So total 18 types of database or 18 types of architecture can be designed, 18 types of distributed database management system can be designed based on different types of autonomy, different types of distribution, or different types of heterogeneity. 3 cross 3 cross 3, 3 into 3 into 3, total 18. Means we can design or we can perform a architecture of distributed database management system of 18 types. So some alternatives are meaningless or not practical. So out of all the alternatives, when we see the combination of autonomy, distribution, and heterogeneity, so some of the alternatives are meaningless, and some of the alternatives are not having practical implication, not having practical values. Okay, so we will see how we can use autonomy, distribution, and heterogeneity for different kinds of distributed database management system architecture. Okay, the major DDBMS architecture is based on client server, peer-to-peer, and multi-database. So we will see one by one what is client server. Okay, so under client server, here you see the distribution of the architecture of the database is written AX D1HY. It means we are having, as I have already discussed here, autonomy will be described by A, heterogeneity will be described by H, and distribution will be described by D. Okay, so we have three options, A, D, and H. Okay, now under client server, AX D1HY, it means it is distributed the functionality between the client and the server to better manage the complexity of the DBMS. This is two-level architecture. This is a two-level architecture in which we have taken into consideration the autonomy, distribution, and homogeneity or heterogeneity of the database. If we define such kind of database, if we are going to design such kind of distributed database management system in which we have used autonomy, distribution, and heterogeneity, and it will be defined, it will be indicated by different symbols AX, D1, and HY. It is known as client server database model. Okay, so the typical scenario under client server is that the client parses a query that is decomposes into the independent queries and send it to the appropriate server. Each server processes a local query and sends the result that is relation to the client. The client combines the results of all the subqueries. Okay, these are the three scenarios under client server model or client server distributed database management system. Okay, now second is peer to peer, means if you are distributing your database between one to one person only. Okay, you are the user or you are distributing your database with only single user. This kind of process is known as peer to peer. So it is defined or it is indicated by A0, D2, or H0. So under this kind of architecture, under this kind of design, we will have global users that can submit the request via an internal schema, that is ES, or you can have global conceptual schema, that is GCS. Okay, so peer to peer means you are dealing with single user only. Your database is only accessed by a single user. Your database is distributed so that only a single user can access your database. This is a kind of peer to peer process. Okay, so it defined over the global conceptual schema, that is CGS, which is system maintained, and that is the union of all the local conceptual schemas, LCS. So it includes global conceptual schema as well as the local conceptual schema. The global system has no control over the local data and processing. Now moving to the next slide. So what is multi-database? So multi-database means when you are distributing your database globally, so you need to use global conceptual schema, that is GCS. It exists as a union of local conceptual schemas. Means, as we all know that under the distributed database management system, database is also distributed on the local network. Okay, and all the local network combinedly perform or combinedly create a global schema or global conceptual schema. So the global conceptual schema is also having some local conceptual schema, that is a kind of local data set stored at a local computer or local network. So under multi-database, we need to include global conceptual schema as well as the local conceptual schema for creating or for designing a distributed database management system. So it is defined by or it is indicated by A2DXHY. A2DXHY is the architectural design that represents the multi-database system, that represents the multi-database management system of the data. Okay, so the three orthogonal dimension of the data distribution is having level of sharing, it is having access of the pattern behavior, and the level of knowledge of access pattern behavior. So what are the level of sharing, how much data you are going to share, what should be the access of the database, and what kind of knowledge or how much access pattern is there when we are going to deal with the dimensional database of the distribution. Okay, so this is the way in which you can have the distribution of the database. It is having access pattern behavior, then level of knowledge, and level of sharing. So when we see access pattern behavior, it should be of two types, whether dynamic or static. Means you can provide the access in two ways, dynamic access or static access. How much data you want to share, what is the level of sharing. It is having three types of sharing. Either you don't share anything, either you share something, or either you share something and hide some data set. That is three kinds of sharing. Then level of knowledge, either you are going to distribute, either you are going to describe the entire information, complete information, or some partial information. So level of knowledge is also of two types, level of sharing is of three types, and the access pattern is having two types, that is dynamic and static. So in this way you can perform the distribution of the database. You can do the, you can create a distributed database management system having three kinds of pattern: access pattern behavior, level of sharing, and level of knowledge. Okay, now moving to the next slide, that will show you the three orthogonal dimension, that is a level of sharing. Under level of sharing, if we are dealing with no sharing, so each application or each data executes at one site. Or you can say the data sharing having the programs that is have replicated at each site, and data not replicated but moved to the site as needed. And if you want to share the data as well as the programming behind the data, then it is known as data plus programming sharing, under which both data and programs may be moved to a site as needed. So the level of sharing may be of three types: either no sharing, or data sharing, or data plus program sharing, depending on your requirement, depending on your you can say the access level. You can have any kind of data sharing. Okay, so the access pattern behavior is having two types, whether static or dynamic. Under static, you may have the access pattern to the data that do not change over time. That is static database. Static database doesn't change over time, so the same data sets can be accessed by the person, by the user at any time. Okay, dynamic database, it is having access pattern to the data that is changing over time, and how much your database is dynamic, it depends on your requirements. Okay, so whatever the database you are having and how much access you have provided that data, it is depend on the type of data set, whether it is static database or dynamic database. Third one is level of knowledge of the access pattern behavior. So under level of knowledge, okay, there are three scenarios: no knowledge, partial knowledge, or complete knowledge. When we opt no knowledge, means you will not share any kind of information to the other person. That is not a likely scenario. Partial knowledge can predict, but users may deviate significantly. And under complete knowledge sharing, you can predict and no major changes are there. Okay, so these three kinds of orthogonal dimension of the database architecture, having level of sharing, the access pattern behavior, and the level of knowledge. Okay, now the designing of the distributed database can also be of two types. We can have two approaches: top to down or bottom to up approach. Under top down approach, we may have the database and how to partition and or they replicate it to across the sites. Whereas bottom up approach having existing database at different sites, that how to integrate them together and deal with the heterogeneity and autonomy. Okay, so under distributed database designing, we may use top to down approach or bottom to up approach for any kind of database designing, that is distributed database designing process. So now we will see what is top down approach and what is bottom up approach for the designing of our distributed database. So on the top down approach, it's a typical or it's one of the conventional approach to designing a database. And in this approach, information regarding the distribution of access among the sites and the nature of access to the database at each site, it needs to be gathered during the requirements analysis, and it is designed as a local conceptual schema by distributing the entities over the sites of the distributed system after conceptual schema design. And the distribution activity consists of the data fragmentation and data allocation. Whatever the data is distributed under top down approach, it is having two kinds of activities: either data fragmentation, in which the data will be splitted up into different schema, different pieces, and data allocation means it assigns the schema, that is pieces, to the site. Okay, so this is the distribution activity consists of the data fragmentation. Now moving to the next slide. Bottom up approach. Okay, so this approach is important, this approach is vital when database already exists and we do not integrate them into one database. It is very much similar to view the integration but may be heterogeneous. Okay, but if you are having the database, if you are already having the database, so we can apply bottom up approach, in which we may have, we don't need, we don't need to integrate them into one database, and it is very much similar to view the integration but maybe heterogeneous. So under bottom up approach, we may have the existing database. So this is the design of the top down design approach. On the top down approach, first we will see the requirement analysis is done, then system requirement will be performed. Under after the system requirement, we may have two kinds of designing, whether conceptual designing or view designing. When we are going for conceptual designing, so we need to use the global conceptual schema, that is GCS. And when we only want to view the design, so under this we may have two options, that is access information or external schema definition. Okay, and the entire information from the global conceptual schema, access information, and external schema definition will be used for the distribution design, that is distributed database design. Okay, so this is top down design approach, under which we may have the process of the designing of the database from the top down approach. Now moving to the next slide. This is the remaining part of that. Then under this we may have the distributed design, then local conceptual schema is implemented, and if required we will have some physical designing or physical schema, and the observation and the monitoring can be done under this top down approach or top down design. So this is the way we can use the top-down approach for designing our distributed database management system. This is the entire flowchart started from the requirement of the database. Then when we will go for the system requirement, the conceptual design is there. Under conceptual design, we will use conceptual global conceptual schema. And if you only want to see the design, if you only want to view the design, then we will have access information, external schema definition. Okay, so this is the way in which, also if required, we can provide some external input, external user input under distribution design. So this is the way we can perform top down approach for designing the distributed database. And at last we can have the observation and monitoring option to monitor whether our database is very good, or the design is efficient, design is working properly or not. So now, what are the reasons for the fragmentation? When we talk about fragmentation, fragmentation is the distribution of the database into horizontal and vertical components. So what are the reasons for the fragmentation? So the relation is not an appropriate unit of the distribution, and the application views are usually subsets of the relations. The application access is local to the subsets of the relation. The applications at different sites may require different parts of the same relation, that is store at a time or duplicate. When we are on the storing at a time, then we will have the high remote access cost, and that is having the duplicate high update cost. Okay, and the another reason for the fragmentation is that the concurrency of the access is more limited. Okay, so access is limited, so we need to perform the fragmentation so that access will be continuous. We may have the continuous access to the relational database or any kind of database or distributed database management system. Okay, Now moving to the next slide. Okay, but in some applications they may suffer from the data fragmentation, and the data that is required for the fragmentation is located in two or more fragments, and it may be harder to check the integrity constants. So the careful design of the data fragmentation is required. For fragmentation, we may have some important instructions is that we have to check the data integrity. If there is a integrity constants, so during the data fragmentation we have to carefully check the designing of that database. So this is the reason for the fragmentation. So what are the correctness rule for the fragmentation? When we are going to perform fragmentation, so what are the rules that can be taken into consideration during the process of the fragmentation? So first one is completeness. If a relation R is decomposed into the fragments R1, R2, and so on, Rn, so each tuple, or you can say the attribute that can be found in R can also be found in one or more of the rows. Second important rule is that reconstruction. If a relation R is decomposed into the fragments, that is R1, R2, Rn, it should be possible to define a relational operator tau such that R is equal to tau Ri, or Ri is relation to the Fri. Disjointness is third kind of rule that is important for the fragmentation. If a relation R is horizontally decomposed into the fragments R1, R2, and Rn, and data item Di is in Rj, it is not in any other fragment, that is Rk, where k is not equal to the j. So for fragmentation, during the fragmentation process, we need to follow the rules of completeness, reconstruction, and rejointness, so that we can easily perform the fragmentation. So as we already know that there are three kinds of fragmentation: horizontal fragmentation, vertical fragmentation, or hybrid fragmentation. Okay, so we will discuss one by one what is horizontal, what is vertical, and what is hybrid fragmentation. So under horizontal data fragmentation, first we need to know what is horizontal data fragmentation. Under this kind of fragmentation, the partitions a relation along its tuples. Tuples are the number of rows in the table. As already we have discussed, the tuples are the number of rows in the tables. Okay, so the horizontal data fragmentation partitions a relational table or relation along its tuple, so that each fragment has a subset of the tuples, the relation. So these kind of horizontal fragmentation having two types, whether either primary or derived. Under primary kind of horizontal fragmentation, it is totally based on a predict pi that selects the tuple from a relation R. And under derived type of fragmentation for horizontal data, we may have the option of the partitioning of a relation due to the predicts defined on the another relation. So the types of horizontal fragmentation may be of two types, either primary and derived, and it is based on the predict of the pi that selects the tuples from a relation R, or it is derived so that it is based on the partition of a relation due to predict that is defined on the another relation. Okay, so the types of the horizontal fragmentation is related as per the foreign keys present in that table. Okay, so for such kind of fragmentation, or you can say the horizontal fragmentation, we need to first check what is the foreign key, how many types of foreign keys are there in the table. That is a kind of relational database table or relational table. Okay, so this is the example, this is the figure showing the horizontal data fragmentation under the primary type of fragmentation. So each fragments, that is Ri, is a selection on a relation R using a predict P. So the original relation or original table is written here, that is under project name, project number, location, department number, and it is having six different tuples or six different rows. Okay, now we are going to fragment it horizontally. Okay, so when we are going to fragment it horizontally, so we are having some primary fragments. So under here we first fragment all the data into the table that is having department number 5. Then we will have another table that is a fragmented table, that is department number 4. And now at last we will having the table which is having department number 1. So the entire table is fragmented on the basis of a foreign key, that is a department number. So there are three data for the department number 5. So that these three data sets related to project X, project Y, project Z is fragmented as a separate table that is having only the data of the department number 5. Then there are two data sets relating to the department number 4. So that these two data sets are stored, are separated as a separate table having department number 4, and only one data set is related to the department number 1. So that is a web cells, and this data is stored or separated, or you can say the fragmented as a separate table which is only having the data of the table number 1. So this is the way we can do the horizontal fragmentation, and in each fragment it is a selection on a relational R using the predict P. Okay, so now moving to the next slide. Okay, okay, and if you want to use the derived kind of horizontal data fragmentation, so under this we may have the existing primary fragments, that is projects, that is site 1, and project site 2, project site 3. And under project site 1 we are having the data related to the department number 5, then department number 4 is related to the data that is in the project site 2, and project site 3 having the data related to department number 1. Okay, and original relation is having the works on the employee ID and the hours, how much working hour of an employee, that is having different employee IDs. Okay, so this is the derived kind of activity, derived kind of segmentation for the horizontal data. Okay, now we can have the option of the derived, like the existing primary fragments, that is project site 1 which is having department number 4. So it is derived as a separate table, that is derived fragments, that is employee ID and P number, that is a uh, 1 2 3 1 2 3 2 3. Okay, then project site 2 having project name, and on the basis of the project name or P number we may have a separate table, we may have the fragmented table that is derived from the existing table. And now third table is also derived from the existing table, that is a table named as a project site 1, which is having only the data of department number 1. So this is the way we can perform the horizontal fragmentation, either primary or derived kind of activity. Vertical fragmentation produces the fragments R1, R2, R3, and so on, Rn of a relation R, and each fragment contains a subset of R's attribute as well as the primary key of R. It divides the relations vertically by the columns, you can say it attributes, and the objective of such kind of vertical fragmentation is to obtain the fragments or the parts so that the applications can only need to access only the fragments. In that we want to minimize the execution time of the applications. So inherently the vertical fragmentation having more complicated than the horizontal data fragmentation because of the total number of alternatives are available. It is more complicated than the horizontal fragmentation because there are lot of alternatives all available, lot of data sets are available to, so that we can divide the relations vertically in the form of columns or the attributes. So this is the figure showing the flow chart of showing the diagram of vertical fragmentation. So each fragment, that is R, is a projection on a relation R. We are having the table in which the R is reconstructed by applying either outer union or full outer union to all Ri's. Okay, so we are having table that is the columns A1, A2, A3, then A4, and so on, AN. Okay, now it is now uh, fragmented vertically into three different tables having A1, A2, A4, then A1, A3, and A1, then AN. So this is the way we can perform the vertical fragmentation. We can perform the fragmentation of the entire relational database in the vertical format. Okay, this is another example of the vertical fragmentation. You can see here the table is having the employees details, that is employee ID, the name, the address, sex, salary, the marginal ID, and DNO. Okay, so this table is fragmented vertically into two different tables, or you can say the into three different tables. Having first table is having only the employee ID, their name, and their address. Then in the second table, it is having the employee ID and related salary of that employee. Then in the third table, it is only the employee ID, their marginal ID, and DNO. So the entire table is fragmented vertically into three different tables, and each table is based on the employee ID. So employee ID is a kind of you can say the primary key that is used for the vertical fragmentation. And in each table you may have different information. Like in first table, we may have only the name and address of each employee. Then in table 2, we may have only the salary details of each employee, that is a different employee ID of different employees. Now in the third table, we are having only the information about the marginal ID and DNO for each employee. So this is the way we can perform the vertical fragmentation. It is much more complicated than the horizontal fragmentation. Okay, so under vertical fragmentation, the information is required. We need to have some information. It is required to have some basic information for performing the vertical fragmentation. It is having access frequencies that uses the QI and AJ. If one is AJ is referenced by QI and zero otherwise. Okay, now in the second type of second requirement for vertical fragmentation is affinity of the attributes. In this, the number of accesses to the attribute AIAJ for each execution of the application QI at site SK, that is weighted by the application access frequency. So the table 1 and table 2 is showing two different kinds of requirements, that is having A1, A2, A3, Q1, Q2, Q3. And in second type of requirement, that is affinity of the attributes, we may have the information A1, A2, A3, A4, and it is distributed in the horizontal and vertical, or you can say the rows and columns of the table. Now moving to the next slide. Yeah, third type of fragmentation is hybrid fragmentation. So hybrid fragmentation includes both the vertical fragmentation as well as the horizontal fragmentation. In such kind of fragmentation, each fragment, that is Ri, is a combination of a selection using a predict Pi and projection on a relation R. Okay, so it includes both the processes, or you can say both the fragmentation processes from the horizontal and vertical type of fragmentation. So you can see here the entire table is fragmented, entire table is distributed, or you can say the separated into different tables depending on the projection and the selection, that is Pi or Ri. Okay, so this is the way we can do the hybrid fragmentation. This is another example of hybrid fragmentation. So you can see we have a table that is named as project. Under this table, we may have the information about the project name, the P number, the location, and the department number. Now, this table is fragmented. This table is about to fragmented into different tables on the basis of their site information. So the table is having first fragmented table, that is P number and project name. Then in site 2 we are having different P number, location, and department number. And out of all the table information, we are having the department number 1, which can be separated as a separate table, and the department number 4, the information related to the department number 4 will be fragmented as a separate table. So this is the way we can do the hybrid fragmentation. It performs the horizontal as well as the vertical fragmentation. That's why it is known as hybrid fragmentation. Allocation is important. Okay, for a given set of data, a set of fragments, that is F is equal to F1, F2, Fn, or the set of sites, that is also denoted by S, which is S1, S2, Sm, and a set of transactions, T is equal to T1, T2, or Tp. So we may find an optimal distribution of F to S. So this is the process of the allocation of the types of fragments, type of the sites, or the type of the transactions. Depending on the requirement, we can adopt any of the types in any of the allocation types, whether fragmentation, the site, or the transaction. And after that, we need to find an optimal distribution of the fragmentation to a set of the sites. So optimal distribution of fragments to the site, that is F to S, that is allocation. So allocation is required to have minimize the cost. It is used to minimize the cost. That includes the cost of storing the data, the cost of querying FI at the SJ, the cost of updating FI at all the sites where it is stored, and the cost of data communication. And this kind of allocation process, the performance of the allocation or the need of allocation is to improve the performance. It maximizes the performance of the distributed database management system, so that because it will minimize the response time at each site and maximize the system throughput at each site. Okay, this problem is NP hard. So before designing or before performing the fragmentation or before performing the architecture of the distributed database management system, we need to first allocate the data, which data we are going to distribute, or which data we are going to fragment. If we prior if prior to the fragmentation we apply the allocation process, so it will minimize the cost and maximize the performance of the distributed database. That is very important, to minimize the response time, and it will also maximize the system throughout at each site. So this is the way we can do the fragmentation, either in horizontal way or vertical way or hybrid way. And before such kind of fragmentation, we need to perform the allocation process. Allocation process having several properties, several you can say the characteristics that will minimize the cost and maximize the performance. So this is the way we can do the allocation. Thank you very much for today's class. Now we will discuss next topic in the next class. Thank you.